Okay, hopefully should be working. Okay. So on Monday and Tuesday, we're gonna be doing a lab. So here's an extra credit opportunity. If you can bring a water bottle, or if you can donate a gallon, I mean, a water bottle will probably be easier, um, for you. And we do need like a full water bottle for that class period on Monday, but then we need more water on Tuesday as well. So if you can bring it, I totally forgot to remind y'all. If you can bring it, send me a message like today, tomorrow, or early Sunday, because I'm gonna go Sunday afternoon to go buy anything else that we don't have. Okay, so send me a message on Remind or email me that you're bringing it. Okay, and how much you're bringing. Because I'm also gonna get the lemonade powder to make the solution. Okay. And the cups. So I do want them with water in them because we need the water to make the solution. Yep. Okay, so we're mainly only gonna focus on this paper, the front and back of this paper, because based on last period, they took most of the period to do that. There's a Schoology quiz up there, but I don't have it due till Monday night, so if you don't get to it today, that's fine. All right. So let's look at this. So this right here, this is your ticket to lab. So if you on Monday, if you don't have this, you can't start the lab. You can't do the lab. Okay. You'll be in a group with other people that didn't do it. Okay. So explain how to make the following solutions. Include calculations, sentence, and drawing. Okay. So first of all, I can see that they didn't give me the formula. Ammonium nitrate. Ammonium is NH4 plus nitrate is NO3 minus. So if I were to make the formula for this, what would be my final formula for that? What would be the final formula? Can't move forward until we know the formula. So then we have to find the molar mass, convert moles to grams. What would be my final formula for this? What is it? What's my formula? I have NH4 plus, NO3 minus. What's my final formula? No. My final formula should look something like this, right? Not just ions. What does my final formula look like? Yep, that's it. That's it. Because it was a positive one and a negative one. All right, what about this one? This is Mg plus 2. And this is SO4 negative 2. So what would be my formula there? Yep. And then this one's a little more challenging. This one down here is iron 2 Do you guys remember what that 2 meant for iron? How many what? Yeah, it's related to the charge, so Fe plus 2. And then phosphate is one of your polyatomics is PO4, -3. Now this one is not nice and neat like these two, right? They just cancel out. Do you guys remember how to like find the formula for that one if it's not canceled out? Yeah, you crisscross, drop and swap. So instead of Fe2, it's gonna be what? Fe just 3, not the negative. Okay. And then PO4, instead of being 3, it would be 2, and it needs a parentheses. Alright. This is coming back. It's gonna come back to us at the end of next week. So if you don't know your ions, you might want to start reviewing those, getting those papers up. Okay. And then the rest is just what we've been doing. So we're gonna use molarity for all of these. M equals moles over liter. Okay. So to find the grams, because that's what I need in a solution, I'm gonna plug in. So molarity is 4.5. My liters is 6.7. And then my moles, right? And then I'm gonna cross multiply to get the moles. So when I cross multiply 4.5 times 6.7, you should be getting, yeah, 30.15 moles. Which is a lot. That's a lot. Times, well, to get from moles to grams, you have to multiply by the molar mass. So that's 3 times 16 oxygens. I have 2 nitrogen, so that's 2 times, I believe nitrogen is 14.1, right? And then hydrogen down here is 4 times 1.01, right? Which is 4.04. So 4.04 plus 28.02, then plus 3 times 16 would be what? It's gonna be kind of a big number. Yes, 80. Well, I got 80.043, but I mean, as long as it's close to that grams per mole. So then you just multiply these numbers. So the moles cancel out. So you're gonna be a really big number, right? 80 times 30. So when you multiply these two, you get 2,413 grams. Okay. So that's a lot. You're doing this in the lab, that's a lot. So that's your calculation, like that's your answer for grams. That's how much I need to go get. So let's describe how we're gonna do that. So you're gonna measure 2,413 grams. If you wanna write the name, you can, or you can just type or write the formula. If you wanna write ammonium nitrate, go for it. You also do this. You're gonna measure this many grams of NH4NO3 and then add water to the 6.7 liter line and then mix. So now we're gonna illustrate that. Okay. So what would I use to measure something? We've done it in the lab before. Uh, Not a beaker. Like, I mean, how would I measure that it's that many grams? The scale, right? So I know it's kind of weird. I'm gonna draw it like if I'm looking at it from above. So there's the scale, and then there's the solute. And then the scale is gonna read however much I need, 2,413 grams. Although in real life, you probably have to do this in like portions. Do you guys remember so like imagine this is in a bottle probably, this solid. How would I get that solid out of that bottle? Like what instrument would I use? Like if you were in the kitchen, what would you use if you were trying to get, I don't know, sugar mix or something? like a scooper thing or, right, or like a spoon type. So just to show you a picture, right? Yeah, like a spatula or a scoopula, like that, to get it out of the, and then the weigh boat. Okay. And then usually, we put it in something called a volumetric flask. I'm really bad at drawing those, so I draw it like an Erlenmeyer flask, which is fine. So there's your artist skills that works. And then that line is 6.7. What? I'm not an artist. And then you mix. So it's not too bad. So we're going through this because you're literally gonna do that in the lab. You're gonna be measuring the grams, you're gonna be adding water, and then you're gonna be mixing. We're gonna translate this into the lab on Monday and Tuesday, so you'll see it. All right, so let's do number 2, and this time you're guiding me, you're telling me what to do, so. How would I start this problem? So I already helped you by making the formula. What else should I do? What's the next step? Okay. Everybody else, we're good with that? But, so this is the equation, right? I'm gonna write it here. Molarity equals moles over liters. That's why I always like writing the formula first. Yeah, we gotta convert it, right? So how do I convert milliliters to liters? No, how do I convert milliliters to liters? Yeah, divide by 1,000. So, yeah, the 4.5 should go down there, but as liters, right? Which would be 0.0045. Okay. And then what did y'all say to do afterwards? I think I heard something. Good. Yes, good cross multiply. 3 zeros. And what unit would that be? Moles. And then what would I do with that? Yes, times it by the molar mass of this, right? So you do need to show the work for that, even if it's just showing me like this part, like 4 times 16. S is, I believe, 32, right? I don't know. Y'all confirm because I'm just going off the memory from last period. Magnesium, they said it was 24 something. What is it? 31. Okay. Anyway, when you add this up, you should find the molar mass, which is going to be kind of big. 124.31. Okay. Grams per mole. Moles cancel out. So that what y'all get when you multiply? When you multiply 120.31 times 0.0002. Yeah, I'm just gonna stick with that. Okay. So it's a really small number, so they're having to measure a little bit of this material. So what would the sentence be like? You can use that. You can say you can keep it as the original milliliters or liters, okay? And then okay. Okay. So it's the same sentence over and over. All you're changing is the number of grams and liters or in the formula. Okay, and then for my drawing, what's the first part of the drawing that I do? Scale. I mean, you can draw this however you like. I've had students go, they're actually artists, draw a way better scale. Like they'll draw it like 3D. You can do that if you want. And then the second part of the drawing would be what? The beaker or the flask to yeah, to the 4.5 milliliters, which is gonna be really small. It's like a really mini, like a mini graduated cylinder kind of with water. That's why there's a line. And then the last thing is to mix. Okay. So it's the same process over and over and over. It's the same thing. Okay. So that you have the steps for all of these. So you have the formula for this one. All right, just to check, just to make sure, and you have that way you're, because I know some of you guys want to know what the right answer is at the end. So for this one, you should be getting 7.32 grams at the end. So make sure you're showing me all the work to get to that point. Okay. This one, you should be getting 22.02 grams at the end. So your job is to do everything else to get to that answer. Then include a sentence and a drawing. If you're not getting that, let me know so I can help you. Now, go to the back, go to the next page. So it's the same thing, but on this one, I just ask you to calculate it and show me a picture, not everything. So you can do it however you like to do that. And then 1 through 4 are just practice problems for dilution. Any questions about this?